Thanks for watching this video. The topic of conversation today will be what's up with the weather. As we begin to exit summer 2015, it's been quite remarkable how moist it has been, especially in Southern California. We'll take a look at that and the weather pattern for Southern California. Here's the precipitation across the United States from June 20th through recently up to September 17th. Quickly, you can see the upper Midwest, northern Rockies have been very wet, and pockets of New Mexico. Most notable is the region that usually doesn't see rain in the summer, and that's Southern California coastal areas, as shown here in purple, much above normal precipitation. And here we look at the temperatures for June through August. So here we're leaving out September. We can see most of the summer much above normal, hot in the Pacific Northwest, and most of California above normal as well, especially northern. We can see Northern California has been very dry, very little precipitation. And notice the precipitation, however, across the Sierra Nevada and Western Nevada, much above normal. In Southern California, it's been complete opposite from the Pacific Northwest. Much unusual weather and wet conditions along the coast and valleys, and very dry across the Pacific Northwest. This takes a look at the temperature and precipitation for June 20th all the way up to currently through September 17th. You can see this also includes the precipitation we received from the tropical cyclone Linda. Southwest California continues to stand out as the wettest across the west, much above normal. Very unusual to see that kind of rainfall in the coastal regions. But despite the rain, notice it remains warm along the coast and above normal, more than 2 degrees above normal along the immediate coast, and the warmest area being the Pacific Northwest. All right, what are some culprits and some reasoning behind why it's been so warm and wet? Well, we know El Nino has formed. That began in May of 2015. There's also two regions of unusually warm water in a large portion of the Pacific Basin. We'll call those Blob and Blob 2. Those areas have been persistent. They've been around for the past couple years, and over the past year have shifted eastward and remained along the west coast. Now, normally in other significant El Ninos on the right-hand side, you can see that El Nino zone is pretty much the main player. It's very obvious in historical El Ninos how strong that zone is, and other regions of the Pacific typically aren't that much above normal, nothing compared to what we've been seeing over the past year to year and a half. How has this affected our tropical season? Well, in 2014, it was very active with 20 named tropical cyclones in the Pacific. Their tracks are shown here. The highlighted ones are in yellow. Those affected us mainly in September, but also in late August with the powerful Marie. Okay, in 2015, it's also been very active along the Pacific, and we are already up to 17 named storms with still a couple months to go. And most recently, we've received moisture from Linda, but we also had significant impacts in July from Dolores and even Blanca. Here are the tracks shown on the right. All right, let's take a look closely at the weather pattern across the Pacific in 2015 to see if anything is noticeably different. The weather pattern in the upper left, well, we can see there's been warm across the North Pacific in the upper part of the atmosphere. That's high pressure aloft. Not much signal across the equator, though a little bit of warmth along the equatorial region. Let's take a look at how this has looked like as the standard weather pattern in the bottom. You can see weak low pressure area has been persistent just offshore of Point Conception as shown in the lower left. How about down into the lower part of the atmosphere? We can see that extreme warmth shows up in the atmosphere at about 5,000 feet. And this is an important region that creates our temperatures here in Southern California. Extremely warm temperatures have extended from the Baja region, Eastern Pacific, and into the California Bight, and even extending into the Intermountain West. Also, note the very moist region at that same level. Very moist conditions have shown up over the course of the entire summer in that same region of very warm temperatures. And if you remember the prior slides, this is also located near blob number 2. On this slide, we'll focus on looking at has the jet stream or any jet stream departed from normal. Immediately our eyes see the high and low pressure area. That's the upper level high pressure that's been dominant in the North Pacific through the summer and last winter. Notice the gradient between the two. That's created a stronger jet stream in the polar region cutting across the Gulf of Alaska, as indicated on the right. All right, and you can see the much less wind than normal at jet stream level under that high pressure area. If you look now down towards the tropics, looking for a signal from El Nino, you can see that there is a little bit higher wind speeds than normal at jet stream level that go from just north of Hawaii, cut across towards the Baja region, and then dive across Central America and into the Atlantic Ocean, where hurricane generation is significantly impacted. How about the typical monsoon? Well, that moisture comes in the middle and upper levels, so closer to where the planes fly, 15, 20,000 feet, some cases as low as 10,000 feet in deep monsoon moisture. We can see there's been quite a bit of a monsoon, but it's remained across the California, Mexico, Baja region and into New Mexico. Remember we looked earlier and we saw anomalously high precipitation in New Mexico. Then we also have another region of separate Pacific moisture which has been in place across northwest California. And then of course down near the tropics has been quite active around Hawaii with lots of deep moisture in that region showing up. All right, let's compare El Nino years to what we've seen this summer. Well, this is what typically happens with El Nino years of the past. It typically is cool and much cooler than normal in the summer months, and we have not seen that really anywhere in the West. The relationship to precipitation in the summer, the white areas don't show up very well. Do note, however, that in the east slopes and parts of Nevada, they do seem to have a relationship with El Nino being wetter. Arizona tends to be dry with those stronger El Ninos. And then look at the Gulf region, which has been locally wet, tends to be very dry. Pacific Northwest tends to be wet, and they've been much drier than normal. So we're only seeing some indications of what we've seen in the past El Ninos. So other things are likely going on in the atmosphere. Here's a summary. 2015 continues to be much above normal across the West. And though we've seen some cooling across Southern California finally, specifically in May and also the month of July where there was quite a bit of rain. And in 2015, moisture has been notable in Southern California. This has resulted in warmer overnight temperatures, muggy conditions, just much higher humidity, and also could be a culprit to some of the significant rains that we've seen. The sea surface temperatures of the blob area has been significant and persistent, and it's moved into the California Bight this year. 2015 summer months brought much above normal precipitation. A lot of this was attributed to tropical cyclones such as most recently Linda. 2015 and 14, the tropical cyclone season in the Pacific was very active both years. El Nino started to develop and had significant warming back in April and May of 2015. However, the blob region of warm ocean temperatures, it's been around for a while, since 2013 and 14, and it slowly shifted eastward. This blob was created by the upper level ridge of high pressure blocking pattern in the atmosphere or very warm air aloft that prevented us from getting any storms and allowed that water to warm significantly, really over the past 2 years. Past El Ninos, however, are not correlating well with temperature in California, and there is a little bit of correlation with precipitation in some parts of the West. El Nino cannot be credited for all this warmth and wet weather, however, And the historical correlation is for the winter months and into the spring. We have had unusually warm sea surface temperatures, the blobs, and these have not been seen before with past El Nino years. So we don't have much reference or historical information to go on about what this might mean and what this is doing to our weather. But we're starting to see some indications as shown in this presentation.